much, James. Thank you everyone for joining me this evening, and I hope you're all doing well. As James put, my name's Joe Cox. I'm a cybersecurity researcher currently at the University of Gloucestershire, and today's talk will be on navigating the path to Web3, opportunities, challenges, and the role of blockchain. So, with that being said, we'll just briefly go on a bit about me. So, currently, I have obtained, as of last year, a first-class degree in cybersecurity, which I completed from 2019 to 2023. In that time as well, I was also for 1 year doing a placement year, but I was actually still with the university as a research assistant within the blockchain lab, working very closely with my colleague Sepida on learning everything there was to know about blockchain. So everything my start point was from about 2021, so going on nearly 3 years ago now. But now my current role is I'm still with university as what's known as a PGA or postgraduate assistant. So this is where I will assist with lecturing on both computer science and cybersecurity modules. But at the same time, I'm also undertaking my PhD alongside the PGA, looking into blockchain for the security in the financial sector. So with that being said, I guess we can make a start on a quick history lesson, because we all love history. So the idea of this is to show you guys how we are evolving with the internet and the World Wide Web. So first off, when we first started with the web in the 90s, we had known as Web 1 or version 1, which was known as the static internet. The core aspect of here was you would search information, that information would be outputted to you. Of course, we still all do that nowadays, but that's all the internet was primarily used for at the time. However, in 2004, we saw a new band of technology come through with Web 2, and focusing more on user-generated content. So this was sort of when Facebook sort of started up, and then all these other social media channels such as Instagram and Twitter came along, and how you can have users that generate their own content, whether through video, audio specific, and users having a bit more personalization with their data. Of course, YouTube also being a big part of that. But since then, we have moved to more a Web3 version of the internet, or where we're going towards, and how we do this is through a decentralized management and through more being user-focused. Because at this current moment in time, some of you may not know what Web3 is, but I'll briefly explain it. So Web3 is essentially taking what we have with Web 2 and that user-generated content and all this data, and moving it to a decentralized format. So currently, a lot of the internet runs through centralized organizations or centralized entities that control this data. Not necessarily inherently anything wrong with it, but at the same time, users feel like they should be in ownership or control of their data. And of course, we can see many data leaks that have happened in recent years that may push this theory further. But the idea of Web3 is at its core is a better control and interaction of users and their data. And of course, the security and the transparency of that data, and the idea that we don't need any intermediaries. So that concept of you are in control of your data and you should be able to do what you choose with it. So with that, there's been many different ways that we are moving towards Web3, many different technologies. However, the one I'm going to focus on, which has been the one most commonly associated with Web3 at this current moment, is blockchain technology. And if anyone wants to leave stuff about questions and stuff, please do in the chat. I won't be able to monitor it until the end anyway, but if anyone else of the BCS can just, if there's any questions that need immediate answering, just let me know and I'll mute your mic. Okay, so blockchain technology. What is a blockchain? Blockchain is a system that runs on what's known as a peer-to-peer network. So this is less reliant on devices that you would typically see in a network, such as switches, routers, and focuses on individual computers known as nodes. And what you do is all the interactions you do over it are known as transactions, and everything you do over the network will be recorded and added to the rest of the chain. So transactions are typically, you will do a transaction between one person and another, or a system, over the blockchain. And what it's to do is it will take your transaction, place it into a block, and then that block is added to the rest of the blocks forming the chain-like structure. The purpose of this is to fully see to all users what type of transactions are going through. So the decentralized nature is also public, so you can see what type of transaction is being done, and also mutable nature. So by design, once a transaction has been done and confirmed on the blockchain and gets added, you won't be able to change how that transaction is done. So if you've inputted something, as let's say my name, that gets put into a block, I won't be able to go to that block and to that specific transaction and change it. It's physically not possible. If you were to try it, there's nothing stopping you from trying it. However, I wish you luck because you need very large computational power to do so. And currently no one has been successful in altering data once added to a blockchain. But I will go on with what could disrupt that in the not too distant future. And what you may have known it from is cryptocurrencies such as Bitcoin, Ethereum, Solana, and many others, or primarily use blockchain technology behind them to make them a cryptocurrency. So in a blockchain cycle, we typically see transactions happening like this. So a user will make a transaction request. That transaction then gets added to a block. This block contains many other transactions from other people over a public blockchain. That blockchain is sent to all nodes, or all participants are going to be either known as miners or validators. And what they will do is they'll check the transaction over and they will validate it, or in terms of, well, with validation, you would have it where they would essentially stake what and solve cryptographic puzzles to say, okay, I'm going to validate this transaction to add it to the rest of the chain, or reject it if they feel like it's malicious. Through what's known as the mining process, which is an older form of validating blocks, they would use large computational power in with these solving cryptographic puzzles that would then validate it. And the first one to do it would then validate it and add it to the rest of the chain. The reason why, though, we have these nodes, these validators, these miners, is because they actually get rewarded for being a participant over the network in the form of some cryptocurrency. So typically, if it's mining over Bitcoin, they will get rewarded a list amount of Bitcoin. Other ones through staking, they'll just get rewarded with the cryptocurrency that's tied to it. Primarily, proof of staking is being done through the Ethereum blockchain currently. Then as soon as it's been validated, it gets added onto the block gets added onto the chain. And then everyone on the net will be updated so they can see all versions of the block, of each block. So you can go back and see from the very first block of Bitcoin, which was around 2009, if you so choose. And then the transaction cycle is complete. Also to mention, within the block creation, every user will have to pay something what's known as a gas fee. Now, gas fee works as sort of like a service charge over the blockchain. Essentially, what you will have is once you say and want to confirm, I'm going to do this transaction, it will ask you, can you pay X amount of cryptocurrency? This tends to be much, much smaller than if you were just to send actual crypto across. But the point of this is this gets put into a pool together, and that gas fee crypto is what's used for the validator's reward system. The purpose of it as well, and the original design of it, was to defer people from doing denial of service attacks, as it will get very costly very quickly. And also they will need larger computational power to achieve denial of service over a blockchain. So I'll briefly go over what actually makes up a block in the blockchain. So typically a block will have a header, which is basic details of said block, like the number and whatnot. Also the current hash of the block. So every block has a hash tied to it. It will also have the hash of the previous block. This is what actually makes the chain-like element. So you would have the hash of the previous block, that forms a chain state, knows which one to connect to, and this forms that immutable structure. Timestamp, so you can actually see what time the block was added, and also the individual transactions when they were done. For transactions actually getting put into the block, as you can see in the list of transactions, this depends on the blockchain itself. So, for instance, most Ethereum-based ones, such as Ethereum, Polygon, and the Binance chain, will do it every couple of seconds. They'll add a new block. Where like so Bitcoin actually adds a block every 10 minutes. It's just by design. You'll also have the nonce, or what's known as the number only once. So this is that unique number tied to the blockchain. This stops certain types of attacks happening, more typically known as a replay attack. You also have the Merkle root, which is this tree-like structure, if any of you know about it, where it essentially ties the leaf or the node's list of transactions, and it has a hash of said transactions, which has a hash of transactions, and so on until you get to the root hash. This is just used for data verification and make sure that you don't have to download the entire blockchain data to see a specific transaction's validity or where it is. And of course, as I said before, list of transactions. So this can be, if it's over a public blockchain, this will be anything from crypto payment, interaction with a smart contract, buying of an NFT, all this other stuff. If you have what's known as a private blockchain, these are blockchains that are specifically designed for set group of individuals. So if we're all on here on the private one, we've been preset by an admin group to do so. And then you have consortium or permissioned blockchains, which is essentially you are allowed to join if you want to. However, you need to get permission before joining on. Whereas public, you can just join on, no problem. So the access point, how do we access this blockchain? Well, typically it's in the form of crypto wallets. So what these will do is they don't necessarily officially have your cryptocurrency within them. Your cryptocurrency exists on the blockchain. However, this is a private part where the crypto wallets are used to access those assets over the blockchain. So they handle your private keys and make sure that all blockchain assets you have are only yours and yours to look at and manage. You can actually, I don't know if any of you know this, but you can have hardware and software-based crypto wallets. So hardware ones, or cold wallets as they're typically known as, like these tiny USB devices, can be used also as an authentication method. But the purpose of them is to anything you don't want to directly interact with and you want to say as like your savings account almost, can be used for these hardware wallets. Software-based or hot wallets is where you have cryptocurrency and other assets over the blockchain where you can directly interact with as soon as you would log into them. So examples of these software wallets are on the right, some of the images. So you have MetaMask, which is the Fox, which is the one I typically use. You also have Coinbase, and you also have Phantom. Certain crypto wallets allow you to connect to only certain blockchains. Some are a bit more open about which ones you can connect to. So it all depends on which one you want to go down. If any of you are looking to ever go down into cryptocurrency and trade and whatnot, if you're looking down the Ethereum route and the Ethereum-based blockchains, I would recommend MetaMask personally. So I've talked about blockchain, I've talked about sort of the very basics of how it works. However, since 2009, we've had different versions of the blockchain. It's not stayed the same. The first one, blockchain 1, was very, very simple. It was essentially you make it how you have the cryptocurrency, you trade across the crypto. That was it. All blockchains still run on this concept. Of course, Bitcoin was the starting point by Satoshi Nakamoto, who we don't know the official name of, or if it's a group of people. But their idea was to create a cash system, a digital cash system that wasn't reliant on any third parties and had no centralized autonomy over it. So this is where we typically see, so for instance, Bitcoin has largely stayed the same over the years, especially since 2011 when Nakamoto officially left the project. But all cryptocurrencies will use this system of you have crypto, you don't want any more, you trade it over to someone else, and away you go. However, people realize the potential of blockchain, especially in for processes and security. So we found and moved on to blockchain 2.0, which was the addition of the Ethereum blockchain a few years later. And the idea that we have this Ethereum, you can use it just as Bitcoin, that's absolutely fine. But now we are introducing something called smart contracts, which is a key area of research for me. So smart contracts are essentially, if you ever look at them, they're simply just a simple bit of code, but they essentially do the rules and the regulations behind your interaction with the blockchain. So for instance, they can do access control, authorization, making sure you're complicit in certain processes. The idea behind this was, instead of just trading, we can now open up to interacting with code. So for instance, like with smart contracts, I have developed one where it allows you to do voting over the blockchain and then verify who the voter was, and ensure the smart contract ensures that if you voted before, the state of the blockchain realizes he's already voted at this time, okay, they cannot vote again. But that's the very basic smart contract. So you would have external wallets, those crypto wallets, to interact with it. You'd insert your own data into and interact with certain functions. These functions are all set on predetermined rules. So for instance, they require you to have this before you can actually do this. And it keeps that autonomy in check and enforces that you abide by the rules. Now, some problems that people have with smart contracts. They exist only on the blockchain itself as a transaction, which is fine. However, Because they're on the blockchain, they also become immutable. So they will work, however, you cannot change the code once it goes on there. This also means if you have bugs or if you have logic flaws within it, those will also be immutable as well. So that's why there is test networks and where you can actually test and see and do an isolated environment to make sure that your smart contract is up to date. There's also plenty of companies out there that will do security auditing based on smart contracts specifically to make sure that yours is up to security scratch and you don't come into many flaws, because at this current moment over the blockchain and web3 based infrastructure, smart contracts are the main area where people can exploit because of the weak code behind it, and then exploit it for financial gain or to disrupt services as well. Other areas in where smart contracts are being used, IBM have actually their own blockchain called the Hyperledger Fabric, which you unfortunately will have to pay for as a license. But they partner up with Walmart, which is a groceries company, massive in America, and they use it for their supply chain. So from groceries, from its raw material products and into their stores, basically a glorified track and trace service and verifying the data over all the nodes. So everyone who's on the supply chain who needs to be can verify and see and track where the materials are going over at the current stage. However, interaction with this rawly on the blockchain to many simple users over the internet is not great. People won't understand the code, how the functions work with. So we moved on to where blockchain is today with blockchain 3.0. So this is more the addition of the front end side of things. Sometimes fancy looking apps, sometimes simple looking, you won't even know they're on the blockchain, but they're known as dApps or decentralized applications. The idea is that the blockchain then replaces almost a database and becomes the back end, and you have the front end that feeds data to and from the blockchain. So again, exclusively, you don't actually have to, it can run on the peer-to-peer network, so you don't necessarily have to have a blockchain. As case in point with the example that I've put as an image to the right there, Tor, if any of you know, is one of many applications that allow you to connect to the dark web. Officially, it comes under a decentralized application, doesn't use blockchain behind it to achieve the decentralized factor, however, uses different individual nodes and no centralized server to create the dark web and actively use it. But it actually still falls under and is still, of course, very relevant today. For examples, JP Morgan have launched massive company with the financial sector, launched many applications that people have bought into to identify and look at, can we make cryptocurrencies a viable trading service, replace the current financial infrastructure. Chain analysis will look at the same sort of thing, but also looking at the security, making sure that users are verified within their transactions and you're not essentially scamming people. And of course, as I mentioned before, Tor as a less so about blockchain, but I thought it'd be quite fun to mention because I'm sure many people have used Tor before as a decentralized application. But where we want to go and where is the plan to take Web3 is to blockchain 4.0. So this is the idea that we move the internet fully to this Web3 structure as I first discussed. Now, it doesn't necessarily, now currently there are many decentralized applications like a JP Morgan, like a chain analysis, like some of the stuff I created with a voting project and my dissertation at undergrad, looking at how medical records can be used over the blockchain and how we actually interact with these things and how they can be easier managed and making users at the heart of their health data. But these apps are few and far between currently. And currently that much of the web is still controlled by centralized elements. So blockchain 4 is essentially moving to, can we get this entire internet that we have into the Web3 decentralized manner? With this as well is the addition, controversially, of the metaverse. So this idea of a digital environment or landscape where we can do business, interaction, leisure stuff. The whole point of the metaverse and of Web3 is that a transparency and be able to see all data, not necessarily alter it in blockchain's case, but seeing it all and providing clarity and trust to all users. So virtuals have been explored slightly at the moment. So Meta, I'm sure many of you are aware, with their headsets are very clear on how they want to achieve with their metaverse, but also you can also check with NVIDIA, they're also looking at the metaverse as well, and plenty of other companies buy that too. Okay, so as well as the elements of interaction and these applications, you need to be able to still store stuff. You can actually connect databases to a blockchain, so sending data through the blockchain to verify it and then actually stored on the database. That's fine. People in this research area have called into question, though, we want to achieve mass decentralization. If we're still having a simple database, we still have centralized elements that can be still a single point of failure. So there's now the introduction to decentralized elements or decentralized storage. So one of the most common ones is IPFS, or the Interplanetary File System. The way it works is you will upload a file to the IPFS that's running on individual's computer in a decentralized manner, and you will receive a hash back for that file. If you need to retrieve and read the file, you will input the hash and you'll be able to retrieve it back. This doesn't necessarily need blockchain to run, but again, is a decentralized and peer-to-peer based protocol. The benefit and Filecoin does something very similar, but actually more tied into cryptocurrencies and the concept of verifying digital assets over and storing, say, certain files, images where need be. Benefits of this is files have the benefit of being retrieved quicker. So instead of going to a centralized database, you would instead go to the nearest geographical node and be able to retrieve it much, much quicker. But however, people have called into question, again, like blockchain, IPFS and Filecoin are publicly available. That also means that anything you do, if you lose your hash, or if the hash is known by another person, they can view that file. So bringing into question of, well, you need to make sure sensitive files, will they need to be encrypted? You can actually have a private IPFS, like a private blockchain, where you predetermine who actually can use this storage, decentralized storage. But then again, it brings up questions of, we have a centralized admin controlling who can actually be on this certain IPFS system. But this is the way in which we are now bringing together on-chain data and off-chain data, because they go hand in hand still very commonly, and how with Web3, they're massively, massively important. Because the biggest elephant in the room, and everyone's here at talking point on the blockchain, is NFTs, or non-fungible tokens. Now, yes, you may see the image to the right. They are typically an image like that, but also they are anything that is a digital asset can be turned into an NFT. And every NFT is unique. A blockchain will not care about the actual image itself. What it cares about is a unique identifier that is the actual NFT that goes behind it to verify it. And this will be tied again to your crypto wallet and to your user identification. So you can actually see over the block, because they all go over the blockchain, and track and see who's the current owner of a certain NFT, if it's publicly available, and who was the current owner and who was the creator. So you can see that version in history in a more streamlined manner. Case in point, we have the Bored Ape Yacht Club, which is the image you can see on the screen. So this is a group that have generated many, many images of a bunch of monkeys. Instead of actually drawing them or just simply dragging them over, it works on a generation system. So for instance, there is weight added to every element of the image. So for instance, the color of the background, the fur of the monkey, the facial expression has, the accessory it wears. So for instance, certain colors, like for instance, if you ever see one with gold fur, it rarely ever gets generated with gold fur, brown being the most common. So you know that also again jumps its scarcity value and of course raises the prices for anyone who's actually willing to buy or sell them. But more so on using it for artwork, and yes, there has been used for many scams as well. People have decided to take this idea of, we have a unique identifier for a digital asset. Why don't we use that for something else? So Proppy Incorporated and Cocky NFT have done this, especially on the likes of Cocky NFT, which are blending the physical world and the digital world together by using NFTs as a ticketing system. So if you want exclusive events to music venues or sports events, you would essentially have the NFT equivalent, and it essentially proves your ownership of a ticket. And it's much, much more difficult to try and forge an NFT, and it's much quicker to verify it than it is of a physical counterpart that could be also counterfeited. So these are sort of the areas where NFTs come into play, but I still mention them here because it's important for that proof of ownership over the blockchain and over Web3 based infrastructure. So just quickly, this is what's a typical NFT cycle that I've drawn up for you. So creators will have their own crypto wallet and they'll have an image of their choice that they will then typically begin the process of minting that authenticates and verifies that this is going to be an NFT. And then you would pay the gas fee and then it'll be placed on usually a marketplace. This marketplace can then be viewed by buyers, sellers, and whatnot. And you can view specific NFTs, very quickly the history of them, who's created them, the price of them, the price gone over time. But if users want to buy them, they will initiate the buy transaction. Also, there's a sell transaction, which essentially transfers NFT over to an individual. So, for instance, you will be the sole owner of that current time. If you then sell it, you will lose complete ownership and complete control of what you do. You can select royalties on NFTs if you want to as well, but it's only a percentage. But there's also now been the idea that we have rentable NFTs. So we can give the NFT to someone as an ownership, but it's essentially on a time lock. And as soon as that time expires, that NFT ownership is then gone back to the original creator. But here's what I mean by, as well, guys, by the off-chain element. So blockchain will have the update the blockchain and everyone that this is the new owner of the NFT. However, as well, the idea of storing files and images on a blockchain is still quite unwanted because of just the large size it can bring to the blockchain and the unnecessary gas fees you may need to pay. So hence why a lot of the images of the actual NFT go onto IPFS or Filecoin, and then the hash is actually, because the hash is only a fixed bit length, goes onto the blockchain to verify the user. And then, so that's now blockchain, essentially in a nutshell, and the elements of blockchain. What does this actually mean for Web3? What does this mean? What can it bring to it? What challenges does it bring? Because, like I said, it's not just blockchain that makes up Web3. However, I've chosen to focus on it as a key research area and the key front runner to this new age of the internet. But as I've harped on for this entire talk, we have the idea of better transparency and trust. We can clearly see all transactions, all interaction that goes over the blockchain, in a sense, over the internet. The idea being that we can essentially see if something malicious happening, we can identify that and not choose to not trust it. And also, if we can see, okay, someone's had this asset for a while, I can see and track that they've done everything cleanly, I'm more likely to trust them. As well, that immutable ledger. So this is about referring to security side, the integrity of data. Once data has been recorded onto a blockchain, that cannot change from the moment it was added. So adding that integrity, and of course you still have the availability because you can clearly see that. And then finally, ensuring the transparency of not just transactions, but everyone's interactions as well. I label it as transactions because that's just what the typical term for blockchain is. It's all transactions. With that better transparency and trust is a more semantic web. So now I'm talking about we can bring in stuff like AI into the mix, and we can now have something that is more machine interpretable metadata. So essentially, Web3 and the centralized web would allow for better understanding of users' interactions, what people like, what they don't like. Of course, we use that AI element to understand, to make decisions, to identify trends, and see the future of certain applications or the web and where we are going towards. And with that, we've got now machine interpretable data tied to a user. You get a more personalized web experience, which is, of course, difficult trying to compensate for very, very large groups of individuals. And how do we incorporate them clearly in terms of usability, scalability, and the security? If we can now, with a more semantic web, with a decentralized architecture, make it more personal to the user, so every sort of interaction doesn't feel the same, and it makes it much easier on the individual itself. Also, security. So as I said before, the immutability of the entire chain, adding that integrity factor onto all transactions and all the data. Clearly seen as well that with that immutability, the distributed systems are all nodes. So we can clearly see what is going on, what's happening over the blockchain, and what could potentially happen next. And of course, with these miners and these validators, they will validate the transaction. And there's an incentive, as I said, the gas fees to do so. And they will validate every transaction to ensure that this is verified and this is safe to go onto the blockchain. And of course, finally, again, this is happening a little bit back more to NFTs, but can just be for simple cryptocurrencies and other assets. proof of ownership. So everything that's on the blockchain and essentially tied to your crypto wallet is tied to you. So you can verify you are the owner of certain digital assets, and you can pass it over to other people who have the correct access control. You can track and trace past and current owners to make sure that it hasn't gone awry and it's gone from creator to this person to this person. You can very much clearly see, okay, I have this NFT. I want to make sure it's okay. I can see the creator created it this time. I can see it's gone to many, many users. So if many users have had it and interacted with it, then it must be somewhat good instead of just going from creator to a new owner. And better control of the physical counterparts. So this is now bringing more in that, again, that physical element. So people have used it for stuff like digital twins and that concept of owning and saying, right, I have the digital format that helps me verify the physical format. Or people have looked into, for instance, real estate, how we can have a physical or have a digital document that is tied to your house and verify that you are the owner and controller of that house and you can do as you please with it. And like I said, when I brought up rentable NFTs, if you have landlords with tenants, then you can be able to assign over that document as they are the occupant for that brief period of time. And once that time's run out, that ownership and that tenancy proof goes away because, of course, you have to move and then it can be moved on to the next person. However, of course, I've been a big advocate of this. It's not all sunshine and rainbows, unfortunately. There are some very key disadvantages in right now that Web3 has to be adopted largely because it's existed, as you saw in the first few slides, this concept has existed since 2014. So we're going on 10 years now, but we still haven't seen a mass adoption of Web3. One of the main reasons for that is centralization. So as much as it's easy to say, I'm using the blockchain, I'm using this, I'm using that, I'm using IPFS as my storage element, you still have the purpose of centralized elements that could play a part. So for instance, a lot of these decentralized applications and apps themselves, the actual front end stuff are still being hosted on centralized servers, on cloud services that are still prone to being centralized in a single point of failure. So you still have that. If they're interrupted, necessarily the blockchain won't be affected, but that user front end from them accessing it in the first place is massively disrupted. And of course, there are many organizations getting involved with blockchain technology and investing very large sums of money into this area. However, these are all still centralized organizations. If they are to build their own blockchains, their own services, well, it still goes through their centralized manner. They can predict the rules and regulations based off their counterparts. So you'll still always have that underlying centralized element. Now, I know people can argue, do we need some centralization? Do we need that sort of authoritative central figure to be able to determine and do stuff rather than having centralizing it turn into a complete wild west? It's something that's been debated very, very heavily in the area. However, I would say the most key area of blockchain and why Web3 is not taking off as fast as people would hope is the scalability factor. Blockchain can handle large amounts of transactions. We see millions of people interacting with it every day. However, if we're thinking scaling up to the whole internet over the whole world, currently in time, blockchain cannot handle that. And there is now the idea that performance is going to be massively affected. I first saw this when I did the voting system. So the idea is, yes, it is possible to do. I coded it and testing everything. However, if we wanted to scale us up to, let's say, mass general election, and the idea that over 40 to 60 million people can vote over this system, the idea is it will be deeply affected and the performance will be slow, and you could have a case where it gets disrupted to a point where people can't actually interact with it again. So at that moment in time, the scalability and how does it handle, how does security get handled, how does performance get handled, is still a massive question mark. And this is affecting the overall usability of it, understanding of the technology and its ability to grow. And of course, another one is the regulation side of things. So currently, when we're looking at laws and governments and stuff, we want to achieve mass decentralization over the internet for all users across all countries. Well, certain countries and certain places have regulations of the internet. Some places may not even allow access to said internet, if depend on the government. But the idea is that if you can't have it, if you can't even get access to it and we can't even regulate it, what's the point? And what I mean by the grey areas, it's not necessarily a bad thing to use it. Of course, cryptocurrency is completely legal again in the UK. However, it's the idea of the mannerisms we use it is the massive area. the laws in which how we use it and how smart contracts are maybe slightly too enforced, because everything's got to be predetermined. So you can determine X, Y, Z, and it'd be just too much enforcement. Is that bad on the user side of things when we think about if they need to be able to do this and this, if they're being regulated harshly, can they do those things? Again, this is leading to the adoption and the growth being a lot slower than we would like to be. And of course, as well with it, governments don't know how to handle it, whether certain countries have outright just banned cryptocurrencies, and that's one way they've got around it. But how do we incorporate it as well? Certain industries will have regulations of services. How does blockchain disrupt those services? Does blockchain need to adapt to the legislation, or does the legislation need to adapt to Web3 and the blockchain? So again, these are questions brought up. And the final point of this presentation and the concept of quantum computing. The reason why I bring it up and reason why it's really, really important is because quantum computing promises and very soon to bring these high speed, this high processing, do multiple calculations instantly, and just be overall some of the fastest computers we've ever seen. To do this, they would need large computational power, and that's all well and good. However, as I said previously, the blockchain cannot be altered and you need large computational power to do so. Well, there is belief that quantum could disrupt blockchain, and the idea that it will achieve the large computational power needed to essentially start altering stuff on the chain. Again, it's not just blockchain that's affected. All the cryptographic algorithms behind blockchain and its public key infrastructure will also be massively effective. So that's the idea of moving to quantum cryptography. Do we need to create quantum blockchains? But at the moment, this is sort of, again, another gray area about we don't truly know if it will get effective. However, it has a strong possibility of being effective because of the computational power needed. With that being said, I hope you enjoyed my talk today. I'm happy now for a Q&A session. I've also left my work email on there. So if any of you got any questions about what I do, my role at the university, my research, any more you want to know about Web3 or blockchain technology, please, I'm more than happy for you guys to spew a bunch of questions my way, and I'm happy to get back to you on that. Thank you very much for listening. And now I will take any questions that anyone has.
Thank you very much, Joe. That was really, really interesting and very, very engaging and good presentation. So well done for that. Everyone, please feel free to pop in your questions in the chat, and I'm sure Joe will be happy to take these over. Thanks.
Alternatively, you can open your mic as well and just speak to me. I don't mind that as well.
Thank you very much, Joe. My name is Abu. You can see. Yeah, I have a question for you. And first of all, the talk was really, really informative. It's really good. Thank you very much for that. So my question is, what are the main challenges when businesses are transitioning to Web3? So for small, medium businesses to large scale organizations, so what are the main challenges they face when they transition to Web3?
So thank you very much for your question, Abu. So current challenges, like I said, so the scalability element, if they've got current systems in place, a lot of the time they'd be able to reach mass companies, especially over the internet. The idea that if they need to achieve the same amount of users, can Web3 and blockchain handle that? At this current moment, I'm going to say, I'll be honest and completely say, no, it will probably not be able to, especially if you're looking at large organizations, especially if you're looking at places like Amazon and Facebook and all these other large organizations that have large user base. Yes, those services will be affected by it. Also, the legality side of stuff, so especially financial sector and financial institutions have their own legislation that sometimes may be not up to the current speed of the technology. And that's why I said about adoption, trying to make blockchain adopt to the current legislation. However, of course, the idea that the technology moves at such a fast rate, can it also the legislation keep up? So that's what I would say is probably for organizations, those two are the key areas of it, of concern.
Thanks, Abu. Thank you, Joe. I think we've got a question on in the chat from King David. So, question number 1: what are the current challenges of the Web3 system going mainstream, and how soon do you think it would become mainstream?
It's a great question. So yeah, so there is, again, like I said, probably for, again, a user's perspective, again, maybe scalability, but again, they would be more worried about how it actually works, because again, we're seeing with new technology, same with AI, well, how does it work? I don't know how it works. I don't like it. So that's probably a key area as well, why it's not going mainstream. Again, I know I'm harping back to the legality side, but how it actually incorporates not only into the different industries and the services, but also how does the government get involved with it in terms of laws around the technology itself. How mainstream do I think that is? I don't think I can put on a date, because one day I may say tomorrow, the other day I may say, I would say roughly say we're probably looking at a 5 to 10 year period where we're going to see more. Essentially, what we need to see for it is more decentralized applications coming through that solve this scalability and this legal factor. But I would say, all being considered, we can see a 5 to 10 years where we can see large mainstream adoption of it. I see we've got a couple more questions.
Yes. So, second question is: do you think the Web3 will replace the current web system, or they would both run concurrently?
That's an amazing question. In my honest opinion, I don't see the current web system really ever being altered unless something absolutely that disrupts nearly everything about technology. What it will be is, like I said, web is still based off grabbing search information, grabbing it. That's still the, like I said, that's the heart of the web. I think Web3 will just be a more advancement of that infrastructure, but it changing it entirely. Yes, it will run decentralized, but you'll still be able to do the whole searching and finding and generating content. So overall, at the moment, I can't see it being the absolute creative, but I think it will be a more concurrent based running system.
Thanks, Joe. The third question from King David is: are there any security issues with the Web3 infrastructure?
Yeah, like with most places. So Web3 itself is based off, of course, the internet and stuff. So that means going public. So there's that idea of, well, I don't want everything to be public. Like I said, there are Web3 elements that you can make private, but then you bring up the question of, well, it's set users, so it's private, but then if I break through that privacy, I'm in. So privacy is still a main cause for concern, because as much as there is some ambiguity and anonymity to users, full privatization of their identification is not there. So there are still privacy preserving techniques being put in place. And the idea of, I will say, zero knowledge proof is being floated around as an idea, but probably especially the privacy of users is still bringing it up to a big question at the moment. I hope that answers all your questions.
Thanks, Joe, and thanks, King David, for all your 3 questions. We've got a question from Jeremy as well. What about the people that don't want others to see what transactions they make? I know a couple of people that wouldn't want others and the government to see their transactions. How would it handle this type of privacy issue?
Thank you very much for that, Jeremy. So yeah, like I said, so if you don't want anything to be public, you would typically probably move to a private blockchain. Private blockchains usually operate with, if organizations are using blockchain, this is what they'll be operating on. So that idea of, you essentially would set employees and other people within it to solve that idea of being more private. So essentially blocking off even access to the blockchain. That's the first point of privacy. But also privacy as well, zero knowledge proof. So proving who you are without giving up any identifying measures, so name, age, and whatnot. So these are things in which people would be able to do stuff. Of course, there has been connection as well, like I mentioned, about Tor and the dark web. People have been hiding their stuff over the and hiding stolen cryptocurrency over the dark web. Although I will say that is done very illegally. So no one should be doing that. But yeah, I would say that moving towards a private or even a consortium-based blockchain would help with these privacy and issues.
Thank you very much, Joe. Thank you, Jeremy, for your question. We've got another question from David. Do all blockchains work in the same way? Are certain blockchains more suited to different applications like CBDC, ultra low transaction fees, smart contracts, etc.? And how do we make blockchains more environmentally friendly?
Thank you very much, David. Great question. Short answer, yes. There is many. So, for instance, as much as Bitcoin is the most popular because it was the first, in terms of what you can do with it is send over Bitcoin, and that's really it. The most common one to do all of different things is Ethereum, for its ability to have the smart contracts, the support for it as well. So if you look online, you'll see many different applications and different stuff running on the Ethereum blockchain just because it has the overall support. However, it also has the transaction fees are a little bit higher on Ethereum. So when you want to look at transaction fees, there are stuff that's been based off how the spine of Ethereum, known as the EVM. So stuff like Polygon and Binance, which are offsets of Ethereum, but they're their own separate chains. And they're essentially to try and improve scalability. And for instance, as I know from using Polygon, the transaction fees cost less than a penny each time for the user. So that's even better. If you're looking at trying to incorporate sort of all these things, probably the best one I would suggest to look at as well, and for the environmental factor, is Solana. So now blockchains are making a very conscious effort, and these companies who have viewed or have previously made them to move away from the mining process and move towards staking and other proof of algorithms that essentially have cut down the environmental factor by 99.95%. So yeah, primarily it's Ethereum based is the main one that people use. However, there's been also, for wrapping up it all and improving everything, people have started to look into the Solana blockchain as well. I hope that answers your question.
Thank you very much, Joe. Thank you, David, for your question. Simon has shared a link from IBM on the topic of blockchain security. So thank you very much, Simon, for sharing this. We've got a question from Abu Alam. How might blockchain technology adapt to ensure security and integrity in a post-quantum computing era, as you mentioned quantum computing advancements?
Thank you very much, Boo. With this one, what I can speak on to admit the knowledge with me in quantum is not there. It's not my area of expertise, but we'd have to, admittedly at the moment, current blockchain may not be an option. We may have to actually entirely move to a brand new blockchain that is known as a quantum blockchain that can handle, again, essentially stopping that massive computational power. But again, that will bring about, it could possibly be done. However, the environmental factor, which is getting better with blockchain, might be scrapped out the window and might need to go back to the mining process in order to make sure that computational power is not achieved by others to start manipulating it. Also, security and integrity. So again, it will basically need to, as long as it can handle the computational power a quantum computer can output, the confidentiality and integrity of the blockchain can be maintained, but how we go about it may not be the most environmental way we can do it at this current stage.
Thank you very much, Joe. Thank you, Abu, for your question. We've got a question from George. How fast is the blockchain process? Would end users not notice performance derogation compared to existing solutions?
Thank you very much for that, George. For users, the keen eye may notice some parts because of the validation process. However, the actual overall speed is not, to the common user, is not as common. If the network, if it's very public and it's a very large application and large users, yes, they would probably start to notice that derogation. However, with other techniques in place, like I said, not having files stored, having them on the other decentralized off-chain elements, this process, essentially the process of transaction validation can be achieved at a much faster rate. So overall, it's not as noticeable if you're careful. However, if you're like smart contracts, you code poorly, it does become noticeable. So there's There's a lot of other overall factors, but overall not as crazy as people would think.
Thank you very much, Joe. Thank you, George, for your question. We've got another question from one of our attendees. I don't want to pronounce the name, and in case I would spell it. So Web3 and blockchain are major topics. Could you please list relevant websites, papers, and books on BCS website event page?
Yes, we can do that. I can also say it here now because it's been recorded. First point of call always. You can actually track this for papers. If you search up Bitcoin, a peer-to-peer electronic cash system, it's the original white paper by Satoshi Nakamoto that goes over how Bitcoin works and essentially how whoever it was created the blockchain. There's also, if you simply type blockchain review into Google Scholar, you'll get plenty of papers about how blockchain works. There's one from, I can't remember the author, there's one from 2017, which is fantastic at breaking down the ins and outs of blockchain technology in a very simplistic manner. Other websites, IBM's a fantastic source to go to because they have plenty of information about how their Hyperledger Fabric runs and how blockchain runs for enterprises in general. Also, Ethereum have their own website, which they like to big themselves out how the Ethereum blockchain works. But yeah, like I said, all these blockchains actually have their own websites tied to them where you can find information about how they work, how you actually do smart contract development with them, how you also can essentially integrate them as everyday part of your activities and stuff. So if you start off there, we can also list them on the events page, but those are some of the key areas that you can look into as well.
Thank you very much. We've got another question from Stu. When Web3 is referred to as decentralized, it still exists on current infrastructure, which can have outages. How do blockchain-based systems deal with outages? For example, you mentioned the concept of a voting system. What happens if some nodes on the blockchain go down? Are these votes or data stored there then missing?
Thank you very much, Sue. It's a very good question. People have asked me this before. So long as you have at least one person as a node on the blockchain, it will still run. Everything will be sent to them, but it will all still run. So for instance, if we're all on the blockchain and 2 of us, 3 of us go down, those transactions, if we're validating, will still be sent to the other validators to validate. When everyone gets sent the validation or when it gets added to the blockchain, everyone gets sent the same transaction. Of course, it's whoever does the process of validating or mining first that actually adds that transaction. So before, when it was mining, that of course whoever did it first, great, but then whoever did the mining and didn't do it in a quick enough time, that was a lot of computational power wasted. So yeah, overall it can still handle, and that's the idea of you've got no single point of failure. But like I said, with a lot of, there's still decentralized elements. So if you still have centralized elements like some storage of a database, or you have your application still being hosted over a cloud service, if that part is it, then that specific part of your application can still be outed. So yeah, overall, the idea is because of the centralized nature, if some nodes go down, those votes won't be lost. They will still be validated just by someone else instead. I hope that answers your question.
Thank you very much, Joe. Thank you, Stu. Tetinda asks, what role does decentralized finance and blockchain play in the evolution of Web3? Sorry, maybe I missed this point.
That's okay, that's fine. So the point of decentralized finance and what I'm looking into is we don't need to rely on centralized services to audit and validate our transactions. We can simply rely on the technology to do it for us and essentially go from, if I want to do a transaction, I go from A to B instead of going from, I need to get to that person, like I need to go to this place, this bank to validate it and go through all that. The idea is it's more streamlined, it's faster, and it's more transparent. That's the purpose of decentralized finance, but also because you can't alter that transaction once it's added on, it maintains that security and that integrity. Those are the key points of decentralized finance. Like I said, issues, again, the legality behind doing that, because banks would probably still want to get involved because some banks are still looking to how they can do blockchain and decentralized services themselves. That is the sort of purpose of decentralized finance from a user's perspective.
Thank you very much, Joe. I don't see any more questions in the chat as of yet. All right. Anything else, Joe, that you would like to add for our audience?
No, that's all good from my end. Like I said, if any of you want to get into contact with me, my email is on the screen now. So if you want to jot that down, if you want any links to sources and other stuff, I've got plenty of citations, references of academic sources and other websites which I can list for you guys separately if you just want to. And if you want a private chat, just please again get in touch, and I'm more than happy to oblige and help out.
Fantastic. So I think we've got another question from Marvis saying, can we get the slides?
Yeah, I'm more than happy for the slides to be available. Whoever handles that, I'm happy to send it over and it become publicly available for everyone to have as well.
Fabulous. David is saying, thanks, Joe, for a good talk. It was really amazing. And thank you very much, Joe, for all your efforts and for your informative presentation. Peter is asking, will the recording be available soon? Yes, Peter. So it will be available hopefully by end of tomorrow, at most on our BCS official website.